Thanks, Quentin. So again, my name is Everett Dogner, and I'm on the storage business development team at AWS. And I spend a lot of my time focusing on our object storage platforms, where we're going to be talking today about S3 and Glacier, as well as our storage gateway products. And we will spend a little bit of time talking about storage gateway and how it can help you revolutionize your backup and recovery environment. The first thing that I want to talk about is backup and recovery before the cloud. So this might be what you're doing today, or it's traditionally what has happened in the enterprise over the last 20 or 30 years. You have your application servers, you've got your master media server, or it could be called something else depending on which backup software you're using. You're potentially going to local disk for deduplication or for fast recoveries. And then you've also got your tape storage. And a lot of times your tape storage is sent to a bunker or to a silo someplace so that it can be stored offsite. And that might be part of your archiving strategy, and it's also just part of your long-term storage. So this is the traditional environment, and this is what we want to try to augment and potentially make some changes to give you a more robust recovery environment, a more robust archiving environment, as well as save you some money in the process. So before we start to dive into S3 and Glacier and the AWS environment, one of the things that I do want to do is talk about the difference between backup and archive. And we'll talk about how we can help you with both of these at AWS, along with some of our partners. But I just want to be sure that we're talking about the same thing and that it's clear. So backup is your traditional I am making a copy of the data. So I have an authoritative copy, maybe that's on my application server or on a network attached storage device, and I'm making a copy of that so that if the authoritative copy is deleted or changed and it shouldn't be, I can go back and I can recover that data. That's what backup is all about. When you archive data, it's about taking that authoritative copy and moving it. So you may be storing your data on premises today on a network attached storage device or say a Windows server with a bunch of storage behind it, and you're paying appropriately for the performance that and the benefit that you're getting out of storing it on that device. And when you archive it, that means that you're likely not going to be reading it very often or potentially ever again, but you may have an industry or a government regulatory requirement to maintain a copy of that data for a certain number of years or potentially even forever. And so when you archive the data, you take the authoritative copy and you put it someplace secure, not necessarily fast to get it back, but someplace that's secure and durable so that you can read it back if you ever need to. So the first question, why AWS for backup? There are four things that you might be able to achieve moving your backup or potentially even your archive environment into AWS. And the first is reducing costs. Now, this means that your capital expenditures, your CapEx spending for backup storage, for archive storage that you have inside of your data center, whether it's primary, nearline, or tape, it's money that you don't necessarily have to spend if you can shift those workloads into AWS. So you don't have to do the traditional over-provisioning and overbuying of storage that you have capacity to grow into when you move into an environment like AWS where it's on demand and you only pay for what you use. So you can reduce that spending, and certainly you can eliminate the need for secondary sites. If you have data that's being archived or that needs to be stored durably, you're probably replicating that to a second site, and by moving that into AWS, you can eliminate the cost associated with that secondary site. Now, the next thing is to reduce your on-premises footprint, and this means that 30% of your storage footprint potentially can be reduced by moving that second tier backup and archive into AWS, and that also means that you can consolidate your on-premises storage into fewer frames or fewer network attached storage devices so that you have not only a reduced capital expenditure on the hardware itself, but also on the maintenance as well as the cost to manage that. The third will be the change process. And this really goes back to capacity planning and what I said around having to overbuy. And it's pretty common to look at what your storage is today, look at what your growth rates are, and then try and estimate where you're going to be in 24, 36, 48, even 72 months out, and try to plan for that so that when the budget cycle comes around and you buy new storage, you're trying to buy for the future. And that means that you may get it right. You may also underbuy, which is going to raise your costs later on, or you may dramatically overbuy, depending on how fast your data is growing. And that means that you're spending money that you don't need to spend. And so moving the backup and the archive data and even your tier 2 data into AWS, that means that you can reduce the capacity planning that you have to do and take the guesswork out of it, because with AWS, everything is available on demand. And finally, the fourth thing is remove aging technologies. And this is really centered around tape for archives, old disk arrays that may still be in service, specifically for purposes of backup or potentially even archiving. And being able to get those older arrays and those older tape libraries out of the data center and replace it with cloud-based storage in AWS, again, can reduce your management overhead, as well as reduce the maintenance costs that you might be paying. So let's take a minute to talk about the AWS storage portfolio. We have block, file, and object available. Today, we're primarily going to be talking about our object storage platforms, so S3 and Glacier. We're also going to talk a little bit about EBS as it relates to data protection inside of the cloud and how you can take advantage of S3 with EBS snapshots. And then down in the bottom tier of the slide there, we will talk about Snowball for initially seeding your S3, your backup, or your archive environment, as well as using Storage Gateway with applications that you may have on premises today to be able to do those backups and archives. So I've talked a little bit about being able to grow your environment on demand with AWS and sort of pay as you grow. And if we compare that to a traditional storage environment, and this is where I say you may be over provisioning or overbuying, and let's say we have 1 petabyte of raw storage inside the data center. So this is physical disk capacity is 1 petabyte. That doesn't mean that we get to use all 1 petabyte though, because we're likely doing some type of data protection with RAID to protect against hard drive failures or mechanical failures inside the frame or the network attached storage device. So in this case, we're going to say that our 1 petabyte of raw storage is now 800 terabytes of usable capacity. And we're going to allocate that as 600 terabytes to an application server so that it has some room to grow, but we're only today storing 400 terabytes of data. So our 400 terabytes of physical data is being stored using 1 petabyte of raw storage. So that means that we've probably overpaid and over-provisioned for our 400 terabytes. And I know that there are a lot of technologies that have come along in the last few years, things like thin provisioning, that try to help address this problem. But just from a capacity planning standpoint, as well as what you're going to be purchasing and provisioning, this is still a real problem in many data centers today. And so with AWS, with S3, with Glacier, with all of our storage products, you pay for what you use. And that's a key differentiator here. If we look at the object storage platform, the services that we have available, the first is S3 standard. And S3 is one of the oldest services at AWS. This is object storage that you access over the internet. This is for your active data. Very fast access time. You can read the data out, write the data in, scalable throughput, low milliseconds of latency. The next tier is S3 standard infrequent access. And this is for the data that's been stored into S3, but maybe it's not read all that often. Maybe it's once every 90 days or once every 6 months that you actually need access to this data. And so you can tier the data down or even write directly into infrequent access, and you can lower the cost per gigabyte that it costs to store that data inside of AWS. There is a charge associated with reading the data back out. And so that's kind of one of the trade-offs that you can look at between the cost of S3 standard and S3 standard infrequent access for that data that is not read very often. And then the last tier is Glacier. And Amazon Glacier is really the kind of the cold tier or the archive tier. If you think about it in terms of backup, those tapes that you are sending off-site to a vendor that's storing them in a vault someplace, Amazon Glacier is equivalent to that, with the difference that it's probably going to be lower cost as well as you'll be able to get access to that data much faster than if you had to call someone and they had to retrieve a tape, lock it in a box, put it in a truck, drive it to you, and then you have to load it back into the library. So we can simplify the process of getting access to that data, as well as store it more durably. Speaking of durability, with S3 and frequent access, S3 and Glacier, we offer 11 nines of durability. And if you compare that to a tape environment, if we have 2 tapes stored in one site, that's about 4 nines of durability. If we take those 2 tapes and store them in 2 separate locations, that's about 5 nines of durability. So we're getting more than 100% improvement in the durability of the data that's stored inside of S3 and frequent access, and Glacier when you compare it to storing that data on tape. So to take a little bit closer look at those, for S3 and frequent access, it's same durability and throughput as S3, immediate access to the data. You are paying a lower cost to store that data per month, and the caveat is that it is 1 penny per gigabyte to read the data back out. And so what this means for most customers is the data that you're putting into S3 and frequent access, let's say you write in 100 terabytes of data. As long as you're reading out less than 100 terabytes per month, then you're going to be paying a lower cost to store that data compared to putting in S3 standard. Now that could be every single file in that 100 terabyte data set one time, or it could be one single file or object, and you could read it out enough to hit 100 terabytes of capacity. So it's just something to keep in mind when you think about using S3 or S3 and frequent access. It can absolutely lower your costs and give you a great return on the investment of storing that data inside of AWS. You just want to think about how you retrieve the data. And we do have a tool that can help with that we'll talk about in just a few slides. The other part of this slide, Amazon Glacier, again, 11 nines of durability. And we talked about what that means compared to tape. And with Glacier, you have a couple of different options available to be able to retrieve data. So there's the 1 to 5 minute, 3 to 5 hours, or 5 to 12 hours. So expedited, standard, or bulk. And when you're retrieving the data is when you choose how fast you want the data back. So you don't have to think about it when you're putting the data in. It's just when you're reading the data back out of Glacier and getting access to it again. That's when you make the decision, how quickly do I want that data? Now, once you have the data in S3 or in an S3 in frequent access, from a data protection standpoint, maybe you're backing up or archiving into S3 and frequent access as the first tier, you might want an additional copy of that in a separate location. So you can use cross-region replication for that. And cross-region replication means that you might have data in, say, US East 1, and you want to replicate that data to US West 1. So you can set up cross-region replication on the bucket, and any new objects that come in will be asynchronously replicated to the other region, so in this case, US West 1, and you'll have 2 separate copies of the data. So if something happens to the first copy, maybe it's an application error that comes in and ends up deleting a bunch of objects that should have been deleted, you have a separate copy that you can then fall back to. As far as tiering data from S3 to infrequent access and even down into Glacier from S3 standard, we have some tools that allow you to analyze how you're using those objects. And this is important because when I mentioned that there is a charge to read data back out of S3 and frequent access, we give you these storage analytics tools so that you can determine the right time and the right schedule to move that data down into S3 and frequent access, and then even into Glacier. And so you can see that this shows your how much storage you have, what your data retrieval patterns look like, and even based on age of the data, how much data is being read out at a certain age. And so using this, you can then go back and build intelligent policies to say, after 90 days or after 120 days, I want to tier from S3 to S3 in frequent access, because if this is for a backup application, I know that after 90 days, I'm likely not going to need to restore any of the data. So I want to go to the lower cost tier of storage. And then maybe after I don't know, 9 months, you decide that you want to go into Glacier. So you have the ability to set up that granular policy and control how long those objects or that data is on each tier of storage so that you're getting the data on the right tier based on the value of the data, and you're paying the appropriate price for that. One of the other things that we allow you to do inside of S3 and S3 infrequent access is to tag your data. And so if you're going directly into S3, you can write a tag, or you can even apply tags to data after it's been written. And this is just another management tool that you have at your disposal to be able to manage the data that's been put into S3 so that you can write a policy to manage that data based on the tag. With Glacier, I mentioned that this is really equivalent to maybe an archive tier or a cold storage tier where you would send tapes out to a separate location. And so it is optimized for the infrequent retrieval of data. That means that the data that is written into Glacier, it's something that you need to store for long periods of time, maybe even need to store it in a compliant fashion to be able to guarantee that it's not deleted. And because of that, it's not something that you would expect to read out. I did talk about the different tiers that are available for retrieving the data back out of Glacier, so that when you do have to get it, you can control how quickly it comes back out. But it isn't something that we expect to happen very often. And so when you're planning for the data that's being moved into Glacier, you really need to understand how that data is being used to make sure that it's not something that's going to be read back out, say, on a monthly basis, because then Glacier is probably not the right tier for it. Now, with compliance on Glacier, you have the option to set a vault lock policy. So you see on the right side where you have flexibility with the vault access policy. This means that you can update objects, you can delete objects at any time, and you can be able to work with the data that's in there. Even though it's not something we expect you to read out a lot, you can still go in and write new objects or overwrite objects and delete objects that are inside of Glacier with the vault access policy. With the vault lock policy, this means that this vault is being locked down. You cannot update, you cannot delete any objects in that vault after it's been locked. And so this makes the data immutable. This also makes it compliant with things like 17A-4 and other various government regulations where they require you to keep data in a secure fashion and to be able to guarantee that it hasn't been tampered with, as well as cannot be deleted before a certain amount of time. So with a vault lock policy, you can go in and say this data cannot be deleted for 8 years, and any data that is written into that vault is going to be locked for 8 years from the time that it was written. So important thing to keep in mind when you are setting policies on vaults in Glacier as to, is it a locked vault or is it an accessible vault, and what is the time period if it is a locked vault. You want to be sure to get that right, because if you were to say accidentally set it for 20 years when it should have been 2 years, that means that data is going to be locked into that vault for 20 years. So now that we've talked about some of the fundamentals of what is available from a storage standpoint with object storage inside of AWS, I want to shift gears a little bit and start talking about backup and recovery, which is really what this webinar is about. But it's good to set the foundation and kind of talk about some of the things that are available so that as we go through the rest of the webinar, it makes a little bit more sense when I start to talk about S3 infrequent access, or Glacier as targets for backup. So when you're going and doing backup and recovery to the cloud, the first part of the slide there, the upper left-hand corner, is Cloud Connector. And this is where you have backup software, or you have an application that can write natively into AWS, either over the internet or a VPN connection, even an AWS Direct Connect into one of our data centers. You have software that will natively support S3 or S3 infrequent access, or even Glacier, and you can do your backup or do a copy of your backup directly into one of those storage services. So you might be doing a backup to local disk so that you get a fast local backup. You have a local copy for recovery should you need the data, and then you're making a copy of it into S3 or infrequent access or even Glacier. And on the bottom left-hand part of this slide, you can see the cloud gateway model. And with the cloud gateway model, This is where you have an application or you have software that maybe doesn't support the S3 API or the Glacier API, or maybe you have another reason that you don't want to go direct into one of those storage services and you want to go through a gateway. And having a gateway on premises means that you can have an environment that is similar to maybe what you're managing today with tape, only instead of going to a physical tape, you're going virtual and you're actually writing the data in the end into AWS. And we'll talk more about what that looks like. And then you also have the option for doing archiving. And again, with archiving, you may be able to write directly to Glacier or directly to S3 and then lifecycle it down into Glacier if the application supports that. Or you can even do something like write to our storage gateway in virtual tape mode and use that to then write that data into Glacier. And we'll talk more in detail about that. And then from a cloud connector standpoint, AWS has a plethora of partners in our partner program. There are a lot of companies that have invested the time and the effort to have their software applications or even some hardware appliances that will directly connect into the S3 or into the Glacier environment through the APIs and allow you to write data directly into those services. This isn't a complete list. This is just an example of some of the things that are available. So if you have one of the software vendors or hardware vendors that's on this list, you may have direct access to AWS today for your backup and archive. Or if you're using a different company, they still might have direct support for AWS. And certainly you have the option for one of the gateways, which we're about to talk about. So the cloud gateways for backup, again, this is similar to what you're doing today, where you have an application server and you may be writing to a VTL or to backup directly to a tape library today. And this is where we would come in and replace that with something like a NetApp AltaVault appliance or even the AWS storage gateway running in file, volume, or tape mode. And that way you can get that data into AWS and write it to the appropriate tier of storage. So with NetApp AltaVault, this gives you the ability to write directly into the AltaVault appliance, and you get data reduction, so deduplication and compression of any data that's written into AltaVault, and then you can move that data out into S3 and through the different AWS services. So this acts as a backup target that provides deduplication and compression as a service. And there's even some additional integration that NetApp has done between AltaVault and the filers that you may have on premises. So you might want to talk to NetApp about that to get a better understanding of the integration that's available between AltaVault and like clustered data on tap to do things like snapshots into AltaVault. So that's available. I would encourage you to talk to NetApp about that. And then the other option, or one of the other options that you have, because we certainly have more partners, but is AWS's own storage gateway. And storage gateway provides access to S3 infrequent access, Glacier, and even EBS snapshots through a file mechanism, a volume mechanism, or a tape mechanism, and even gives you access to all of the other AWS services that are sort of wrapped around that. Things like CloudWatch for monitoring, CloudTrail for compliance and recording of activities, IAM for identity management, and even KMS, which is our key management service for encryption. So we'll talk a little bit about the three different modes and then go through and dive in a little bit deeper with what you can do. But I mentioned that we have the file gateway. So this is NFS version 3 and version 4, and it gives you access to S3 or S3 infrequent access directly from the gateway. And then you can even lifecycle the data down into Glacier. We have the tape gateway, and this is where we provide a virtual tape interface over iSCSI. The data is written into S3, and you can even move it into Glacier. And then the last one is the volume gateway, and this is where we present an iSCSI LUN that you can connect to as a raw block device, write a file system on top of, and take snapshots into the EBS snapshot mechanism inside of AWS. So to talk a little bit more about gateway, and we'll dive into those use cases and provide some examples. One of the questions that I get asked very commonly is, where does the storage gateway actually store data? And so the storage gateway, when it's deployed on premises in your data center, you can have up to 16 terabytes of local cache. It's deployed as a virtual machine. So you can see in this case, on the left side of the slide, we have data center, and it could be in Washington or in Oregon. And we've got the virtual machine running. We're backing up to it or writing to it as a volume. And the storage gateway is going to store the data in the AWS region where it was activated. So in this case, we have the gateway running in the Pacific Northwest, but it was activated to US East 1, which means that the data is being stored in Northern Virginia. And so in this case, we're doing the backup on one coast, and the final storage of the data is on the other coast. So for the file gateway, I mentioned that we have NFS support natively. We have the local cache for reading and writing locally. And it does make an HTTPS connection back into the storage gateway service and into an S3 bucket. And this means that if you have a backup application, or maybe you want to do database dumps of log files so that you can replay them later, if you have NFS support, and it is supported even in Windows operating systems, then you can mount the export. You can write that data into the storage gateway virtual machine, and it will transfer it into S3 or into S3 frequent access. You can actually choose when you create the NFS export which tier it's going to go into, and then you can build a lifecycle policy to move that data down into Glacier. So maybe if it's your database logs or even sys logs, maybe you decide that you're going to write those into S3 standard and leave them there for 30 days, just in case you have to do a restore or get the data back. Then you're going to go into S3 and frequent access, or maybe even straight to Glacier, where you're going to leave that data for maybe 6 or 9 months or even 12 months. And at the end of that time, have a policy that says, when the data ages out, I just want to delete it automatically. And so you can automate that process of the data being written into the gateway, transferred into AWS, and then moving through the appropriate tiers of storage at the appropriate time, and even sort of end-of-lifing the data when it's no longer needed and it can be deleted. For the volume gateway, as I mentioned, this is where we present an iSCSI LUN that you can mount to the gateway or mount to your application server. And where this comes into play with a backup and restore environment is that we give you the ability to take snapshots. So the data that's being stored through the volume gateway will be stored back in S3 at AWS, and you can have a snapshot schedule that will snapshot that data and store it as an EBS snapshot, which you can then use either to recover to the same gateway. You can use it as maybe a development LUN, or you can even use it to recover that data inside of EC2 as an EBS volume. So there's some flexibility that you have there to protect data that is maybe on premises in your data center, and you want to be able to have an offsite copy of that data. And the gateway, the volume gateway, works in 2 different modes. And what you see here would be cached mode. And cached mode means that the entire data set is not stored on the volume gateway virtual machine that's running in your data center. It's only a subset of that. So you can have up to 16 terabytes of cache. Maybe you put in 4 terabytes of cache, you have 40 terabytes of data, and we will just be caching the most recently written and most recently read data to the point when the cache is full. But everything will be stored back in the service in S3. The other option that you have is using what we call stored volume mode. And this is where you can take existing data. So in this picture, you can see that we have an application server, we have a SAN volume, it could be Fiber Channel, it could be iSCSI, and we want to shut down the application server, remove that SAN volume, and give it to the hypervisor or the host where the volume gateway virtual machine is running, and then reconnect via iSCSI to the application server. And the application server is going to see all of its data on that LUN, and it's going to just continue working as if nothing changed. But what's going to change on the back end is we're going to take all of the data that's on that volume and we're going to transfer it into the storage gateway service so that you have an offsite copy, and now you can start taking scheduled snapshots of that data. So this is a way to take existing data, existing applications, and enable them to be able to take advantage of backups and snapshots inside of AWS without actually making major changes to the infrastructure inside of your data center. And we even have customers that deploy this and use it as a long-term strategy to migrate their applications into AWS. because once you have the data in AWS and you can start taking snapshots, then you can deploy the application in a test environment in EC2. You can start to make sure that everything is going to work okay and make any fine-tuning or changes to the application that you might need. And then once everything is running correctly, you can do the final cutover and have everything running inside of AWS. So it is an option for things like that, as well as providing a mechanism for you to be able to do snapshots to the cloud. And just a quick customer example for someone that's actually tiering and doing snapshots into AWS is Just Giving. And Just Giving is out of the UK, and they connect charities with donors and allow them to process the payment and to do all of those transactions. And so Just Giving has volume gateways deployed in cached mode, and they're using it for their OLTP and OLAP backups. And so the LUNs have been presented to the application servers. All the data resides on the volume gateway, thin provision LUNs, and they can take snapshots in a scheduled manner to copy that data up into AWS and have an offsite copy for backup. And one of the interesting things that the storage administrator told me about running this environment is that with the storage gateway running, he doesn't have to think about offsiting his backups anymore. It's something that just works. It's in the background, and he checks the logs or the CloudWatch metrics to make sure that everything's working correctly once a week or so, and he doesn't have to think about it. So it's given him some peace of mind just by giving him the offsite copy of that data. And finally, the last thing that we'll talk about as far as the storage gateway is concerned is the tape gateway. And the tape gateway, this fits directly into your backup environment. And so if you have backup software that maybe doesn't natively support S3, or maybe you just want a local copy of the data, even though you'll have a copy inside of S3, you can use the tape gateway or the VTL for that. And so you deploy the virtual machine, and what we do is present via iSCSI the robot for the library, which is the media changer, as well as 10 tape drives and 1,500 slots for you to put tapes in. Now, the way that this works is when you create a virtual tape, which can be up to 2.5 terabytes, if that tape is inside one of the 1,500 slots in the virtual library or is in one of the tape drives, that means that data is sitting inside of S3. If you use your backup software to export that tape using the import-export slot on the virtual library, we will actually copy that virtual tape into Glacier and essentially put it on a shelf and remove that tape from the library. And so that means that you can follow your, maybe pre-established or existing policies when it comes to doing the backup. Maybe you leave it inside the library for 24 hours, and then after 24 hours, you export the tapes, put them in the lockbox, and send them off-site. You can have that same workflow inside of AWS just by writing to the tape, exporting the tape out of the library, and then we will manage copying that tape into Glacier. And then you can log back into the console, select the tape, and we will put that tape back into the library in a read-only format. And so you can go back and re-index and be able to read data off of that tape if you need to restore it. This is also a good archiving tool, because you could maybe take your monthly full backup, and those will be the tapes that you send out to Glacier, and you can leave them in Glacier as an archive until they age out. And we actually have a customer that's doing something very similar, and that's Southern Oregon University. So if you remember earlier when I showed this slide about where does Storage Gateway as a service store data for volume and tape, Southern Oregon University actually came up with the concept, and it's pretty creative, of deploying the virtual machine on their campus in Southern Oregon, and they activated their virtual tape library to US East 1 in Northern Virginia. And so that means that they can do their local backups, and then when the backup is uploaded into AWS, it's uploaded into Northern Virginia. And so for them, they get the effects of a bi-coastal data center. They've got their primary copy of data on campus, even their most recent backups are stored there, but there's always that copy that's in AWS on the East Coast, so that if they ever have a disaster or they have an event where they need to go and get that data back, they can do it from the other coast. Now, the next thing that I want to talk about is Snowball. And so we've talked about some of the fundamental AWS storage services. We've talked about using partner gateways and AWS Storage Gateway to be able to get data in. And we've even talked a little bit about using applications that have direct access through the API. But if you think about moving data at scale, if you have hundreds of terabytes or even petabytes of data and you want to move that into AWS, that can be a painful process moving that over the internet or over a network connection. And so we have the Snowball that's available for that. And Snowball comes in 3 different versions today. There's a 50 terabyte, 80 terabyte, and there's even the Snowball Edge at 100 terabytes. And this is a physical device that you can order from AWS. You create a job in the console, we'll ship you the Snowball. You plug it in, unlock it, load it up with data, send it back, and we will take the data that you've loaded onto the Snowball and we'll copy it into your S3 bucket. So you decide where the data is going to go inside of S3. You pick the bucket in advance. And one important thing to note with the Snowball is that all of the data written to the Snowball is encrypted. So it's got a tamper-resistant and tamper-evident case, TPM chip on the motherboard so that we can make sure that the operating system that is booting up is valid, that nobody's tried to make any changes electronically. And when the data is written, you have the key that it's used to encrypt the data, and you maintain the key. So the key never travels or is stored on the Snowball. So that means that if a Snowball were to get intercepted or somebody were to try to read the data off of it, they wouldn't actually be able to read any of the data because the key is never with the Snowball. So you write the data encrypted to the Snowball and it gets moved into the S3 bucket, and then you use the key to be able to get access to read the data back out of S3. So this is a way to quickly do a first backup, or even if you're transferring an archive environment into AWS without having to do it over the wire. And with Snowball, if we were to send a bunch of Snowballs, say in this case 5, you're transferring 250 terabytes. So you write it out to those 5 Snowballs over 10 gigabit Ethernet connections, ship them back to AWS. In less than 1 week, you have all of that data sitting in an S3 bucket. And so it's a very fast way to move that data. And if we start to compare it to doing it over a gigabit internet connection or even smaller, you can see that it takes a lot more time to be able to do that initial copy of data. So if you're doing your backup and you want to seed the first backup, Snowball is a great way to do that, or even seed your initial archive copy. And so that way your differentials or incrementals that you're doing on a daily basis only have to transfer change data into AWS. And for a great example of a customer that's doing archiving and even reading the data back out, this customer, Halliburton Landmark Services, so Landmark is part of Halliburton. They write software and provide services to the oil and gas industry. And they have an application called Petrobank. And Landmark wanted to move off of an aging tape and network attached storage infrastructure. And so they moved the data into an S3 bucket using the Snowball, and they did their initial bulk data transfer. They used Lambda to inventory the objects that were written and to make sure that everything was correct, and even automated some functions for things like tagging. And then using a direct connect and a file gateway, they're able to read the data back out and even make changes to the data that's written. So the first bulk move of data happened over Snowball, and then any new data that's written or any data that's being changed or accessed is happening over a file gateway. And one of the interesting things about this use case is that by replacing their aging infrastructure, and they were able to stop paying maintenance, and they also didn't have to go through the upgrade process of buying new additional disk or even buying new arrays for the network attached storage, and also replacing their tape libraries. They were able to cut the archiving costs associated with this data by 90%, which is pretty dramatic. And on top of that, they've even reduced the time to data by days or weeks down to minutes or hours. So in the past, one of Landmark's customers would say, open a ticket, that said, I need access to this data that's been archived, I want to work with it. They would have to go to tape, restore the tape onto the NAS and give that access to the application. Now the customer is actually able to do it themselves in real time and get immediate access to that data. And so the last thing that I want to talk about from an AWS standpoint is EBS, specifically EBS snapshots, because it might be that you are doing your backup and archiving from on-premises using a gateway or a native connector into AWS. You may also have workloads that are running inside of EC2, inside of AWS, and you're using EBS for your volumes. So in this case, you can see that we have some volumes attached to some EC2 instances inside of AWS, and you want to take a snapshot of this data, of these volumes. And why this is relevant to S3 is that when you create a snapshot, the first thing that happens is we actually clone all of that data into S3. So now you have a full copy of it sitting inside of S3, and it's managed by the EBS service. And then you can create a clone off of that snapshot, and you can even create additional snapshots, and they build on top of that first snapshot. And what I mean by that is that the first volume, in this case, you can see we have block 1 and block 2. And we create our first snapshot, and we move those blocks over, and they turn into objects or chunks inside of the S3 service. Maybe we delete block 2, we write block 3, we create another snapshot. You can see that chunk 2 is still there. We've written chunk 3. And then we have block 4, and we sort of continue the process so that we build out all of these blocks as incremental snapshots. So the only complete copy that was made was during snapshot 1. We moved everything over, and then for snapshot 2 and snapshot 3, we only moved the incremental changes. So this is the way that you can protect data that's inside of EBS, and you can even do it with a similar schedule and similar workflow to what you might be doing in your on-premises environment today, taking snapshots on your SAN or in your NAS device. You can see here that when you delete the first snapshot, that we will actually remove that second chunk of data because it wasn't present in snapshot 2 or snapshot 3. So as I said, this is an initial clone of all of the data, and then we do incrementals from that point in time. And if you go back and delete snapshots, then any data that was deleted or changed afterward, you will have the most recent versions of that according to those snapshots. So just some benefits of using EBS snapshots. It is durable. We talked a lot about the durability of S3 and of Glacier, and EBS snapshots use S3, so you get the durability that's associated with that. They are incrementals, so after the first snapshot, you are just getting the changes, and you only pay for what you use. There is no upfront charge or provisioning that has to happen for the snapshots. You're just charged as you take them. And you can even clone those snapshots into any availability zone. So that means that you could take them in US East 1 and you could clone them to US West 1, and then you have a disaster recovery copy of that data in a completely different region. So the last thing I want to talk about are some of the partners that AWS has, specifically around our storage solutions. And so we've talked about backup and recovery today and archive, and we even talked a little bit about NetApp and some of the other partners and how they work. But our partners cover a broad spectrum from primary storage to business continuance and disaster recovery, which we didn't talk about today. So I would encourage you to look at our partners as well as talk to your AWS account executive. We have a whole team that manages these partners that are very smart about how they work, the best environments to deploy them in, and understand where they fit and the problems that they can help you solve. We do have additional resources available, so you can go to the AWS website, you can search for backup, archive, disaster recovery to find specific solution pages. You can look for one of our storage competency partners. We also have some partner-provided labs where you can go through the process of deploying and configuring an environment, and you don't actually have to do it in production. You can do it in a test environment. And then, of course, there's the AWS Marketplace where our partners have deployed their software and their tools where you can do a one-click deployment to be able to get fast access to those. And then a couple of select partner microsites. You can see netapp.com/AWS, commvault.com/AWS, and even avirsystems.com/AWS. You can go and look at any of those, and there are certainly more than that. That's just a very small representation. So we do have partners that are available to help with these things. And that's it. And at this point, I will throw it back over to Quentin for questions.